So we have the Chief Technologist, AI, Asia Pacific, Dell Technologies, Aruna Kolluru here with us, and she will talk about convergence of metaverse and digital twins with real-world example. Aruna is passionate about technology, business, and exploring the new possibilities with emerging technologies. She works with organizations to help visualize the art of possible, define use cases, architect and build solutions with AI, ML, DL, big data, and other technologies. She worked in various roles including Cloud Platforms Technologist, Big Data Technologist, Middleware Technologist, Java Architect, and Presales Specialist at IBM and Oracle before joining EMC and Dell Technologies. She has over 20 years of experience in the industry on varying technologies including AI, blockchain, deep learning, computer vision, IoT, big data and analytics, information management, middleware, and enterprise architecture. Welcome, Aruna, for the Day 2 of AI Forum 2022. Take it away.
Thanks for having me. Pleasure to be here. Along with my role, I actually do a couple of other things as well. I'm a member of the National AI Center in Australia, which is trying to advance AI in Australia. And I'm also advisor for Responsible AI Institute, again, for responsibly building AI, building frameworks. So today, I would like to talk about the convergence of metaverse and digital twins, and along the way, we'll actually touch on a few examples. So before we go into the convergence and the applications, let's briefly define what metaverse and digital twins are. I saw a few speakers talk about the origins of metaverse and the 1992 cyberpunk novel Snow Crash. Just want to touch it again, right? Metaverse is a shared imaginary place that is made available to public over the worldwide fiber optics network and accessed using virtual reality glasses. In it, we actually, developers can go build their buildings, parks, signs, as well as things that do not really exist in reality, such as large overhead lights or special neighborhoods where rules of this three-dimensional space we have is ignored, and free combat zones where people can go and hunt and kill each other. Here, I would like to bring up an example. I was talking to a defense organization who is trying to build AI models to detect objects in the war zone. So they deploy these models. They want to deploy these models on drones so they can send a drone and find more insights. But the challenge here is that it is hard to get the images to train the models so that they have what they have done is actually created a metaverse of the war zone. They're using a drone in the metaverse to take pictures of the war zone, and they are using those pictures to train the model in the real world and put it on the real drone. I thought it was a very interesting use case. While gaming and retail and to an extent education industries are early adopters, metaverse is being used by a lot of other industries for some very interesting use cases. Coming to a digital twin is a digital representation of a physical object, process, or a service. A digital twin can be a digital replica of an object in a physical world, like a city or a machinery, or even large items like buildings or even whole cities. Digital twins can be used to monitor existing products and reduce maintenance burdens. Prototyping can be done with digital twins, reducing product defects and shortening the time to the market. Monitoring staffing levels against output or aligning to a supply chain within manufacturing or a maintenance requirements are examples of digital twin use. Monitoring and simulation can improve performance. They can reduce the risk of accidents and downtime through failure, low maintenance costs, and also ensures production goals are not impacted by scheduled maintenance, repairs, and the ordering of replacement parts. Digital twins can offer continuous improvement by analyzing models and testing them in real time. So both digital twins and metaverse are powered by a range of technologies, while AI, Edge, 5G, AR, VR, IoT, all these technologies are considered as different pillars. But we need to think of these technologies, how we can work together with all of those in tandem, so we can actually get to an outcome, right? So if you think of any outcome, not just in the AI space or metaverse space, all these technologies, like you need to capture the data from the sensors. You need the edge solutions there, and then you need to bring in the data to a centralized location where you actually need 5G to transfer the data, and then you need to train the models for AI. And all these technologies should work together in tandem to get to an outcome. And metaverse and digital twins are a couple of examples of that. I would also like to mention here that Dell is a founding member of the Digital Twin Consortium, creating standards and guidelines to build digital twins. I would like to share a reference here. McLaren actually uses digital twins to design the cars. Generally, it takes about 5 years and $1 billion for the R&D for a new model of a car. With digital twins, McLaren was able to produce their first virtual product in 2 years and in less than $500 million. And the time frame for certifying went down from 18 months to 3 days for 150 different variants. And a new model is generated every 10 minutes. This is actually a significant improvement in the cost, efforts, and most importantly, the time, right? They were able to do much more in much lesser time. Also, the most important thing, or like most interesting part, I would say for me, is McLaren car, when they're racing, they have about 300 sensors on each car, creating a digital twin and understanding the race. All the data is processed and analyzed at the edge. Then the data is actually sent to the race engineer to instruct the driver on what to do. You can imagine the latency that is required. So it processes the data, and the race engineer is actually telling the driver what to do, right? So it actually takes less than 22 milliseconds for the whole round trip. You can imagine how important the edge technologies are in this space. When companies interconnect two or more digital twins, we spoke about individual digital twins, but when you can really interconnect those digital twins, you can simulate the complex relationship among different entities and get richer behavioral insights from even more sophisticated use cases and greater value. So an organization might, for example, connects its employee twin and the digital twin of its customers, retail stores, inventory sales, and customer process flows. In this way, it could actually achieve outcomes like simulating an end-to-end impact of business and market changes on a retail store, or optimizing store layouts by responding to the shift in the customer preferences, and assessing different compensation and staffing models by sales, employee performance, and characteristics of a local store, and also enhancing next best product recommendations within the store, and like borrowing patterns and inventory levels. When these twins interconnect with each other, they become smarter as the dependencies and the correlations get incorporated into the modeling, which actually makes it much smarter and gives us more value out of these twins. Digital twins and metaverse, right? To understand how digital twin works in metaverse, it actually helps in designing new products with less effort, resources, and time. Digital twins are used to validate process, and whether it's a manufacturing process or a production process. And then the performance of the digital twin actually captures the data from the production and operations and analyzes it actually to provide actionable insights for informed decision making. The combination and integration of these three types of digital twins are known as digital threads. They can be woven into other products by collecting data at every product and production lifecycle stage. Engineers and developers synthesize physical, manufacturing, and operational data to create a digital twin. All this information, along with AI algorithms, is integrated into a physics-based virtual model, and by applying analytics to these models, the relevant insights regarding the physical asset is obtained. The consistent flow of data helps get the best analysis regarding the asset, making the digital twin act as a live model of the physical equipment. So the convergence of the metaverse technology and the digital twin can bring realism to the virtual world and experiences beyond our imagination, creating exact replicas of reality or even things which are not in the reality as well. So as the lines between the digital and the physical worlds become increasingly blurred, digital twins are widely expected to serve as cornerstones for metaverse and their interactions between the metaverses, which really empowers users to interact and innovate within immersive digital worlds. But to facilitate this kind of real-time processing and time-sensitive decision-making really needs for digital twins to reach to their full potential. So digital twins require the processing of droves of real-time data. And that's exactly where AI comes in. Once sensors and IoT-enabled devices actually collect the data, it is uploaded to an IoT platform to be processed and then further analyzed by AI or machine learning algorithms to determine future scenarios. And again, adding AI, natural language processing, and computer vision, and these digital twins will transform the enterprise metaverse through a wide range of use cases. Now let's actually look at how these technologies are used in different industries. Retail. Appealing customers have become the key in retail sector. Digital twin applied in metaverse can play a very key role in mounting the retail customer experience by creating 3D virtual models of showrooms and products, delivering customers a real-life experience. The digital twin also helps with better in-store planning, security implementation, energy management in an optimized manner. It could be used also to in marketing for product placements, immersive marketing, and NFT-based loyalty programs. It can also be used for product try-ons or product testing as well. There are plenty of use cases in commerce and supply chain as well. By using this high-fidelity digital twins of brick and mortar stores, companies actually can be better showcasing their products and services to prospective customers. This really allows companies to provide an immersive and immersive and actually convenient opportunity for brands to meet customers where they are, really enabling them to shop from the comfort of their own homes. The goal here is to remove friction from the sales process. Instead of needing to come to a store to check out for a laptop, customers can now visit a metaverse location or which is like a digital twin, where they can converse in real time with a live associate. With the help of natural language processing and advanced neural network architecture, the prospective customer will be guided through a personalized sales journey with virtualized environment, rendering in products in real time based on the customer's data or the voice input. Even better, the sales teams can quickly pull up data and use augmented visualizations to compare product offerings, give demos, and better communicate with their customers. While much of the potential of digital twins is yet to be realized, they're simply very powerful, and they actually present use cases for business of all different sizes. The next one is actually healthcare. Medical sector has benefited from digital twins in different ways, right? In organ donation, surgery training, and making other medical procedures less risky. Digital twins with data from IoT can play a vital role in healthcare by improving patient monitoring. It can provide preventative measures for the patients with personalized healthcare. So the metaverse is a paradigm shift in healthcare that evolved, and it really involves everyone needs to be, it really needs everyone to be involved in it. This is because it changes how medical infrastructure is built, how startup costs are covered, and how data security and privacy is handled. The immersive parts of the metaverse are a great way to train the medical staff. Some ways that metaverse is changing is how doctors are trained. Simulation training, in which, for example, trainees get a close-up look at the surgeon's procedure while using tactile haptic controls is one example. And then we have interactive training modules that can make it easier to learn key ideas. For example, VR can take a learner inside a human body and show a 360-degree view of a patient's illness. Digital therapeutics are really becoming more popular very, very quickly with VR and AR in tech and in metaverse. This type of therapy can be used for cognitive therapy, support groups, psychiatric evaluations, rehabilitation, and even physical therapy with help of these haptic sensors. Surgical procedures already use high-tech tools like robotics, so the metaverse is expected to be a useful tool that will help with complicated surgeries and improve care for patients. It also has, metaverse also has caused a lot of buzz and speculation about what it can do in almost every part of the surgery. Surgeons will work on surgeries together with a virtual operating room with the help of other consultants and specialists. Surgeons will be able to see patients' vital signs, pictures, medical history, and other important information on the screen. And then new technology that works with the metaverse can give quick test results in real time to help patients do better. Another area of healthcare that will benefit from the metaverse immersive visuals is the radiology imaging. This is because the metaverse will make possible new things in radiology, like more ways to see them and manipulate the images. Viewing dynamic images, more details can really be viewed by the doctors so that they can figure out what's wrong and what's not better. And it also makes it easier for the doctors to work closely together on 3D medical images. So healthcare is one industry which has a lot of potential with metaverse as well as digital twins, or a combination of them. So many organizations are creating immersive real-time simulations in manufacturing for production lines, manufacturing plants, and factories to identify issues and improvements in the design and production process. Companies have already begun to leverage digital twins to reduce design validation time, accelerate production assembly, and audit end-to-end manufacturing operations, all without interrupting the real-world supply chain.
Solutions with things and tools will continue. Medical exoskeletons will help people walk again. Cars will be gateways to hyper-connected, intelligent lifestyles of their drivers. Fundamental group's future lies in expanding human reach to bring about next wave of change. Smart, connected cars will help people with limited mobility get around. Medical roads will come to you when you need it the most. We need to become the world leader in smart mobility solutions. How do we get there? How do we transform our company to move people in new ways? We need to break from the like one of the Data Technologist delivers. Collaborations with technologists is central to our mobility to innovate. Its end-to-end solution and flexibility helps us build a digital twin of our manufacturing processes, so our engineers can imagine the future much faster. With a leading mobility innovator, we are building the first of its kind manufacturing to manufacture our futuristic products. So, what does manufacturing mean? Combines physical and virtual delivery, and its digital twin will optimize operations. Our manufacturing will also build offers collaborative innovation hub where we can explore mobility ideas in real time. Nowadays, spaces people and technologies takes our global and new experiences we deliver to the church will drive human progress.
Yeah, this is a very interesting case, right? Like Hyundai has actually built a meta factory. Automobiles, digital twins in automobile sector can create a virtual model of physically connected vehicles. It captures the behavioral and functional data of the vehicles and helps in analyzing the overall performance and connected features of the vehicle. So digital twins help in delivering very personalized customer service for customers. And in future, Metaverse can be a platform for the automobile expos, virtual shows, and their digital twins can help users to have real experience of automobiles through digital twins. So moving into the Hyundai use case, at the Hyundai Motor Corporation, they built an innovation center in Singapore. Engineers use 3D digital twins to reimagine the future of physical mobility, both meta-mobility and mobility of things, as well as how they can transform manufacturing in first ever meta factory pilot, which is actually a facility which is powered by Dell Technology Solutions. From the metaverse comes the meta factory to accelerate its innovation and the efforts to achieve this vision. The company opened its innovation center in Singapore as a global open innovation hub. This hub combines 5G, AI, Internet of Things, robotics, edge, and cloud computing, and all the other advanced technologies like 3D digital twins. As virtual proxies, digital twin enables engineers to simulate products and processes in the metaverse without the time and cost or the risk associated with the physical design process and process validations. This hub also provides the world with a human-centered smart manufacturing platform, which is again the first meta factory, metaverse-based digital twin factory that will be verified through a small pilot electric vehicle production facility and then adjacent test track. So researchers and engineers can interact with their 3D virtual simulations in real time, either shoulder to shoulder or over great distances. So Dell Technologies' customer relationship with Hyundai is changing the face of automobile development, design, and experience delivery to customers. Using our integrations, including Dell PowerEdge rack servers, Dell Unity XT storage arrays, data protection, and ProDeploy, Hyundai has taken the innovation to a next level. They have imagined and created sleek bodyworks over wheels and drivetrains, multiple smart mobility solutions that move customers emotionally through the creation of the Meta Factory, a digital twin factory based in the metaverse. All this is delivered through the infrastructure and powered by Dell Technologies. So operating this lab and Meta Factory requires a flexible IT model backed with a wide range of sophisticated technologies. These include powerful computing workstations or displays, software, servers, storage, and a range of technologies to better use and share data to drive innovation. The facility added an OpenStack cloud computing platform as well.
We believe that anybody, wherever you are in the world, can contribute and participate in the conservation and protection of the reef.
The Great Reef Census is an approach in which everyone can help us capture sort of a snapshot in time around reef conditions.
We're working with the citizens of the Great Barrier Reef on their data model, so being able to use analytics to help analyse these photos automatically.
Then those photos can be used to update maps that help better understanding of the reef and conserving the reef.
The goal is to create lasting positive impact.
What we're developing here is absolutely scalable to the Coral Triangle in Southeast Asia, to the Caribbean, to the Red Sea, to the Pacific.
We're at the frontier of a new era of conservation with people power at its centre. Become a citizen of the Great Barrier Reef at citizensgbr.org.
We are working on the citizens of Great Barrier Reef. So these Citizens of Great Barrier Reef is an organization. It's a non-profit organization which uses people power to scale conservation efforts for Great Barrier Reef and the reefs around the world. The organization actually uses leading science, innovative technology, and truly cooperative approach to drive significant conservation outcomes. The citizens team brings diverse range of expertise from those that have been connected to the reef for thousands of years and those across the world who have collective passion to conserve and protect it for the future generations. Over the past 2 years, we at Dell Technologies have been working in close partnership with the citizens of Great Barrier Reef to amplify its conservation efforts using technology. Dell Technologies worked to understand the scientific requirements and developed a deep learning AI model, really analyzes every pixel in the image to classify the coral and reef infrastructure in under 10 seconds. Humans then verify the accuracy. So the platform we have built enables every citizen scientist to go and select a segment of the picture like you're seeing on the bottom right corner, select that category and say what kind of coral it is. So we are actually giving the power of labeling or really identifying how much of coral is active and how much is not. And even though it's called a Great Barrier Reef, it has 3,000 small little reefs. How do we actually get to understand which reefs really need conservation or prioritizing which reefs have to be conserved? These efforts are in addition to what the government is doing. We are able to touch more reefs with the technology. So you can actually see the power of technology and how the 21st century conservation is changing the way we apply technology to it. Again, AI is based, this solution is based on AI, but we are actually planning to see how we can build a digital twin of the whole thing, right? Like really capturing the data from the different sensors, create a digital twin, and in future maybe a metaverse as well, where people can experience Great Barrier Reef from their own backyard. So Dell Technologies has everything you need, right? Expertise and guidance. We have validated solutions which are actually tested and validated for different kinds of solutions, whether it's metaverse or AI or digital twins. We have validated solutions which have been tested in the lab. And then we have solutions customized for your own environment, right? We can build the solutions for your environment, for your problem. Please reach out to us if you have any questions. And with this, I would like to pass on to questions.
So we have the first question for Aruna. Aruna, since AI models need a lot of data to train, how we can build a digital twin model for a new object?
AI models need a lot of data to train, and how do we build a digital twin?
Sorry?
I would like to repeat the question again. Since
yes.
AI models need a lot of data to train, how we can build a digital twin model for a new object?
Sure. So digital twin is actually not just a model. Digital twin is capturing the data from the live object, right? For example, you can think of it as a plane, right? If the plane is a real physical object, a real physical plane, which will have a lot of sensors, and we'll capture all the data from that and we'll create a digital twin of that, right? And then we actually use models which we have actually got from earlier to impose on that and see how we can simulate that. There are different kinds of digital twins. One is actually simulation twins, which really see how you can simulate a particular process or an object or something and see when something might fail. And then we also have process twins, right, which are really capturing the data from live and actually giving us the information of something failing in real time. So there are two different things, or you can actually have multiple kinds of digital twins. AI will play an important role because you're looking at those patterns and finding those models, creating those models. But it's actually one part of the whole digital twin.
Thank you, Aruna. We have one more question down to you from the audience.
Sure.
What are the advantages McLaren had in Formula One by having the digital twin over other competitors?
Sure. Like you've seen on the slide, they actually reduced the cost by half, and more importantly, the time by half. Right. So when they actually needed like 5 years to create a new model of a car, with the digital twin, they're able to do it in 2 years. Right. So it really reduces the time of that innovation cycle. So if something is going wrong, they can actually change the models and create more. So that's one part of it. The second thing, as I said, they have this digital twin of the car, which is actually connecting all the data from the sensors, which are more than 300 plus sensors on the car, while it's racing live, and analyzing that in real time in an edge data center, and giving back the insights to the driver. So they actually give back the insights to the race engineer, who instructs the driver on what to do. Whether he has to brake or what he has to do, right? So it has to be really quick. You can think of how quick the Formula One race car goes, and then analyzing the data and instructing the driver needs something really, really powerful. And this digital twin, which is processing at the edge, processes everything under 22 milliseconds. The whole round trip is 22 milliseconds. They're able to understand more about the live condition of the car, so that they can make those decisions.
Thank you, Aruna Kolluru, for the insightful session.